This assessment asks us to predict the product of hydroboration of the alkyne 6-methyl-oct-1-ine. We have to start this problem by drawing the structure. Working backwards in the name, it's an octyne, so we can go ahead and draw an 8-carbon chain where carbon 1 is the first carbon of the alkyne, so this would be carbon 1, carbon 2, 3, 4, 5, 6, 7, 8. And we're going to have a methyl at the 6th carbon, 1, 2, 3, 4, 5, 6. Even though this is a stereocenter, there's no designation of R or S, so we can just show it as undefined. This is the octyne we're going to use. We're doing hydroboration, which typically proceeds through anti-Markovnikov. We end up with the hydroxyl group initially at the least substituted carbon in our enol. So we're not showing the mechanism here, but we're making the point that the hydroxyl group is going to add to the less substituted carbon to this enol intermediate. Let's make sure we have the correct number of carbons. We've got 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. So we take a lot of care to make sure we've got the number of carbons correct. We want to make sure that we don't lose points on an exam, not because we don't understand the chemistry, but because we leave out a carbon. So always be careful about that. Now, this enol is only going to be an intermediate. It's actually going to stabilize to the more stable carbonyl. It says here that we expect a ketone to be the product, but when a terminal enol or an enol at a primary carbon tautomerizes, we actually get an aldehyde as the product. So the product of this reaction will be an aldehyde. Let's draw in that aldehyde carbon. This is carbon 1, and now we'll count 2, 3, 4, 5, 6, 7, 8 with a methyl at the 6th carbon. This aldehyde will be the product of the reaction. And the hydroboration of a terminal alkyne will always give an aldehyde as the product.